Hey, welcome. Today, we are going to pull back the curtain on fractions. And seriously, forget everything you remember from a dusty old chalkboard, because we're going to look at them as a simple, really powerful tool that, trust me, you use pretty much every day. So, let's get right into it.
All right, first things first, and this is a big one. Pizza, cake, or chocolate? Which one is your go-to? Just pick one. You got it? Okay, good.
See, it doesn't matter which one you picked, because if you've got to share it with someone, you need a fair way to split it up. And that, right there, is where fractions come in. They are literally the language of sharing.
Okay, so let's start at square one. Section 1. What even is a fraction? Well, when you boil it all down, it's just about understanding parts of a whole. A fraction is just a way to talk about a piece of something, not the whole thing. You know, like the fraction 3/4. All that means is you have 3 parts of something that was originally cut into 4 equal parts. That's it. Now, every fraction has 2 key players. You've got the top number, the numerator, which tells you how many parts you have, and then there's the bottom number, the denominator, which tells you how many equal parts the whole thing was cut into in the first place. So it's always what you have over the total.
And this is absolutely crucial, probably the most important rule. That denominator, the bottom number, always means equal parts. I mean, think about it. If you slice a pizza into a bunch of random, wonky pieces, you can't really call one of them 1/8 of the pizza, right? So equality is everything. And here is the one single unbreakable law of fractions. The denominator can never, ever, ever be 0. Just try to picture it. How do you divide a cake into 0 slices? You can't. It just doesn't make sense. It's mathematically impossible. So just remember, 0 is a total no-go on the bottom.
All right, section 2. Fractions aren't just these weird ideas floating around, they are actual numbers. And just like any other number, they've got a specific place they live, right there on the number line. So let's go see where we can find them.
Okay, let's take our friend 3/4 and put it on the map. First, you just focus on that little space between 0 and 1. The denominator is 4, right? So you chop that space into 4 equal chunks. Then you look at the numerator, which is 3. So you just hop 3 chunks over from 0. And boom, right there. That's where 3/4 lives. Here's a little pro tip for you. If you ever have a fraction that's actually bigger than 1, like 5/3 or something, it's way easier to figure out where it goes if you turn it into something called a mixed number first. And don't worry, we're going to cover exactly how to do that. Which brings us perfectly to section 3, meeting the whole family of fractions. Yep, there are 3 main types, and once you get to know their little quirks, working with them becomes a whole lot easier. So here they are. First, you have your proper fractions, like 3/4. These are the ones you see most often, and they're always less than 1 whole. Then you have improper fractions, like 5/4, where the top number is bigger than the bottom. That means you have at least 1 whole thing, maybe more. And finally, you've got mixed numbers, like 1 and 1/4, which is just a tidier way to write an improper fraction. So how do you switch between them? Well, to turn an improper fraction like 7/3 into a mixed number, you just divide. How many times does 3 fit into 7? Well, it goes in twice, and you've got a remainder of 1. So that means you have 2 whole things with 1/3 left over. Your final answer? 2 and 1/3. And what about going the other way? Let's take 2 and 1/4. You kind of just work backwards. First, multiply the whole number by the denominator, so 2 times 4 is 8. Then add that to the numerator you already have. 8 plus 1 is 9. That's your new top number. So you get 9/4, or 9/4.
All right, section 4. This is where fractions get, well, kind of cool. They have this secret identity, like a superpower. It's what we call equivalent fractions. All this means is that you can have fractions that look totally different on paper, but they represent the exact same amount of stuff.
I mean, just think about it. Is there any difference between eating half a pizza and eating 2/4 of a pizza? No, it's the same amount of pizza. The fractions 1/2 and 2/4 look different, but they are the exact same value. That's all equivalence is.
So how do you find these things? It's actually super simple. You just have to do the same thing to the top and the bottom. You can multiply both by the same number, or you can divide both by the same number. By the way, when you divide, that's what people mean when they say simplifying a fraction. And here's the fantastic little trick to check if 2 fractions are equivalent. It's called cross-multiplication. Let's say you want to compare 3/4 and 9/12. You just multiply diagonally. So 3 times 12 is 36.
And 4 times 9 is also 36. If the numbers match, they're equivalent. It works every single time. It's a great test.
Okay, we know what they are, where they live on the number line, and we even know about their secret identities. Now it's time for the final showdown, comparing fractions. Which one is actually bigger?
Let's ease into it with the simple case first. If the denominators, the bottom numbers, are the same, like in 3/8 and 5/8, that means all the slices are the same size, so it's easy, right? Would you rather have 3 of those slices or 5 of them? 5 is obviously more, so 5/8 is the bigger fraction.
Okay, now this next one can feel a little weird at first. What if the top numbers are the same, like 2/3 versus 2/5? This time, you have to look at the denominator. And here's the trick. A smaller denominator means bigger slices. So would you rather have 2 huge slices from a pizza cut into 3, or 2 smaller slices from a pizza cut into 5? The bigger slices win every time, so 2/3 is the winner. But what do you do when the top and bottom numbers are different? Well, this is the ultimate method, the one that works for everything. You just use what we learned about equivalent fractions to give them both the same denominator. Once the bottom numbers match, it's easy. You just compare the top numbers, like we did in the first example. And all that leaves us with one final thing to chew on. We've seen how it works, but really think about this for a second. Why is it that when you divide something into fewer pieces, like a half versus an eighth, each one of those pieces actually gets bigger? It's kind of the central paradox of fractions, and once you really get your head around that, you've basically mastered the whole thing.